A question to dia hoise a 100 ohm resistor is connected directly across a 10 volt battery. Mane amak dia goise eta 100 ohm value resistor aru a to directly ami connect kori disu eta battery across it jar voltage to dia hoise 10 volts. So tamane amar given value hoise R is equals to 100 ohm or V is equals to 10 volt. The first part of what is find the current through the resistor. To amar ei current or value to ulabo lebo kiman hoise. To ami jano from Ohm's law amak koy V is equals to IR. Jehetu amak current ulabo lage to I formula to hobo I is equals to V divided by R. Ami value kini put kori diu. So V hoise 10 volts aru I hoise R resistance hoise 100 ohm. So etu ami solve korile ami pam 0.1. Itia SI unit of current to hoise ampere. So amar circuit to 0.1 ampere current flow hoise. Tamane resistor thurere bitorere 0.1 ampere current to flow hoy ase. Itia ho second part. Amak iti ulabo lagibo power loss kiman hoy. Jehetu current goi ase obviously resistor e kiban hoy kiba energy waste korise. To he kiman power loss to hoise ami etu calculate koribo lagibo. So power loss or formula to hoise I square R. Etu I square R loss buli ko koy. Kisuman formula ase V square over R. Jehetu ami current to itia ulai loisu part it. So moi I square R formula to use koru. So etu hobo 0.1 whole square multiplied to resistance value 100. Etu solve korile ami value pam 1. To tene hole amar power loss hoise 1. Itia SI unit of power ki hoy watt. So amar 1 watt or power loss hoise jetia current 0.1 ampere a resistance or through power hoise. Etia ho part C. How much energy will be consumed in 5 seconds? Tamane energy consumption rate to ulabo lage. So energy consumed will be equals to I square R juntu amar power hoise times multiplied by T. To I square R to ami already ulai thoisu etu hoise 1 watt into time to dia hoise 5 seconds. So 1 watt into 5 second hoise 5 watt second juntu kami SI system joules buli ko. To tene hole amar 5 joules of energy a resistor to consume korile. A question to dia hoise in a 1 Henry inductor the strength of current changes at the rate of 1 ampere per second. Tami likhilo ki bostu kini amak dia hoise. So given 1 Henry inductor tamani inductance value to dia hoise 1 Henry. Our strength of current changes at the rate. The change of current to dia hoise. So di over dt value to dia hoise 1 ampere per second. So parted who dia find the voltage across the inductor. To tamane amar a given inductor L is equals to 1 Henry. Here across at a voltage source logwa hoise. To itia a voltage to iate kiman developed hoise. Hey voltage or value to ami itia ulabo lage VL. Part A. To voltage across the inductor L formula to hoise L into di over dt. Very simple formula. To L value to hoise 1 or di over dt to di hoise 1. To tamane amar hoise voltage 1 volt. Part B. Also determine the magnitude of the energy that will get stored in the inductor after t is equals to 2 seconds. To tamane itia ama ulabo lagibo magnitude of the energy. So stored energy jonto inductor energy stored hoy goise hey value to hoise W is equals to half L I squared. To ita amar L value to already dia ase 1 Henry. Gondogol to hoise current. Ita current to dia na yate di over dt to dia hoise. To etu karone ami ita calculate koribo lagibo. So amak dia goise di the rate of change of current is equals to 1 ampere per second. So di is equals to cross multiply kori diu di equals to dt. Integrate kori diu both sides. So di integration di is equals to integration dt. Itia current to ami pai jam itia kiman 2 seconds after 2 seconds boli koise. To total time hobo 0 pra arambho hoy 2 seconds hole. So I is equals to integration of dt hobo t aru limit value is 0 to t put korile ami pam 2. So tar mane 2 second 2 ampere current flow hoise. So therefore amar energy stored value ho jabo half into 1 into I, which is 2 whole square. So etu value ami pam 2 joules. Equation to dia hoise a 5 microfarad capacitor is directly connected across a 100 volt battery. How much energy is stored in it? Tamne amak dia goise eta capacitor jar capacitance value to hoise 5 microfarad aru ei capacitor to connect kora goise eta battery across it aru battery voltage to dia hoise 100 volts. Jetia ei capacitor to fully charged hoi jabo yar jonto voltage hobo capacitor voltage VC to etu hoi jabo 100 volts. Aru your capacitance value to already dia is 5 microfarad jonto ami likhibo paru 5 into 10 raised to the power of negative 6 farad. To amak ete ulabo lage how much energy is stored in it. To ami energy stored ulabole hole formula to use korim. So energy stored W is equals to half CV squared. It V is a VC, which is equals to half multiplied to 5 into 10 raised to the power of negative 6 multiplied to 100 squared. So etu calculator ami value to put kori dim aru etu amak dibo 2.5 into 10 raised to the power of negative 2. Aru SI unit of energy hoise joules. So ta mane jite ei capacitor to fully charged hoi jabo to yar energy stored energy value to hobo 2.5 into 10 raised to the power of minus 2 joules. So a particular question to dia ase the figure displays an element's current and voltage profile over time. Find the element's type and determine its value. To amar yate duta profile dia ase eta hoise current profile aru eta voltage profile. To actually question to ki hoise amak eta circuit element dia hoise eta unknown circuit element. Ei unknown circuit element ami voltage or eta battery across ot connect kori diu plus V volts jar value to 2 volt hoy. Etia ইয়াৰ যোনটো ৰেসপন্স to ইয়াৰ current response আৰু ইয়াৰ voltage response or graph to দিয়া হৈছে যেতি আমি left hand side ত চাও the current profile to তো clearly ইয়াতে দেখা গৈছে যে ইয়াতে আমাৰ যোনটো current হয় current to linearly increase হৈ আছে with respect to time তো আমি ক'ব পাৰো যে আমাৰ I is directly proportional to time whereas যদি আমি voltage profile to চাও এই voltage value to fix 2 volts ote fix hoise jeta time evolve hoy ase 0 to 5 milliseconds voltage to hotai fixed hoy ase to yate V is a constant or constant to hoise 2 volt tene only clearly eta correspondence dekha pai eta to kotha ami kobo paru je yate I aru V jonto hoy directly proportional no hoy so a jonto element to hoy etu resistor hobo nware not a resistor because resistor case ot ki hoy I must be proportional to V eto to no hoy jehetu to hua nai he karone a element resistor hobo nware eto reject hoy gol maybe eto capacitor hobo pare tene hol ami voltage profile to jetia saw voltage profile to saw at t is equals to 5 millisecond capacitor case ot ki hoy voltage to 0 hoy jabo na lage because capacitor is an energy storing device to tate even though ami battery to disconnect kori do G2 battery voltage er capacitor tok charge kora hoisile hei voltage to capacitor ot contained hoi thakibo he bostu to kitio 0 hoi jabo nware but amar voltage profile ot ki hoise amar voltage profile ot dekha goise je ei voltage to at after t equals to 5 directly 0 hoi goise jonto hobo na lage to tar mane etu kobo parin je ei circuit element is not a capacitor etu hoboi nware capacitor olop holo voltage thakibo tene hole ami ite third alternative ot aizam jonto hoise an inductor etu eta inductor hoy reason to ki hoy mane amar voltage jonto at t equals to 5 millisecond voltage is equals to 0 volt hoy goise tar mane ki ei circuit element to eta short circuit element or nisna kaam korise jonto hoise actually eta inductor to jeta voltage to time 5 millisecond or par hoy goise data voltage to directly 0 hoy goise ta mane potential difference ko create hua nai so ta mane amar a circuit element to actually hoise eta inductor যেহেতু আমি এটো আইডেন্টিফাই কৰিলো এতিয়া আমাৰ নেক্সট স্টেপটো হৈছে এই ইন্ডাক্টৰৰ ইন্ডাক্টেন্স ভ্যালুটো ওলাব লাগে সো আমি জানো ভোল্টেজ across an inductor VL is equals to L di over dt. So L ulabole hole amak ki lagibo voltage across the inductor VL divided by di over dt. So VL junto voltage across the inductor eto ami 0 to 5 milliseconds or bhitorte use korim to VL value to hoise 2 volts. Right? Etia amak next ulabo lagibo the change in current with respect to time. So eto ulabole hole amak lagibo final current or value at t equals to 5 milliseconds minus I initial which was current at 0 millisecond divided by t final minus t initial. So final current or value hoise amar 1 ampere minus initial current into 0 asil aru t final or value hoise 5 millisecond minus 0. So eto solve jeti ami korim to ami pam 0.2 into 10 raised to the power of 3 ampere per second. So ito hoise amar di over dt. So amar L value to hoy jabo. So L will be equals to 2 volt divided by 0.2 into 10 raised to the power of 3. So solve korile ami value pam 10 into 10 raised to the power of negative 3 Henry. 10 raised to the power of negative 3 ami milli boli ko so ami pai jam 10 milli Henry. So equation to dia hoise a steady charging current of 1 ampere charges a 50 microfarad capacitor to retain 10 millijoules of energy. To amak dia goise eta capacitor here capacitance value to hoise 50 microfarad. Etu kami charge kori diu eta voltage V re to kibo current flow hobo ei jonto current flow hoise to steady amount of flow hoise hekani yak charge kori ase to yak current or value to asaise amar 1 ampere to charge hoi thakar pisot olop deri pisot dekha goise je ei capacitor tor jonto energy hoise energy stored in the capacitor energy stored in the capacitor is W is equals to half CV squared. So ami amak ulabo dise ei capacitor kiman voltage hobo such that a W equals to 10 millijoule of energy e store kori rakhibo. Thik ase to ami V square is equals to likhibo paru 2W divided by C. To V hoi jabo square root of 2W divided by C. Iti ami value kini put kori diu. So 2 into energy hoise 10 millijoules. So 10 millijoules hobo 10 into 10 raised to the power negative 3 divided by capacitance value. So capacitance to is 50 microfarad. So 50 into 10 raised to the power micro is 10 to the power minus 6. So jito ito solve korim to itor value ami pam 20 volts. So amak actually a particular circuit to V equals to jodi ami 20 volts diu tene hole ar 1 ampere current jodi flow hoy tene hole a particular capacitor to 10 millijoules of energy store kori rakhi. So equation to dia hoise a 10 millijoule of energy are stored in a 100 microfarad capacitor. To amak tat ase eta 100 microfarad capacitance or capacitor etuk ami charge kori dio ba some voltage source V re dekha goise je ei capacitor to energy store kori rakhise 10 millijoules. To ei information to use kori play amak first to find out koribo lagibo of the amount of energy that is stored there. Thik ase so ami janu je W is equals to half CV squared. To yapa ami voltage to ulai lobo parim to voltage hoi jabo 2W divided by C gute to square root hoi thakibo. Eta ami value kini put kori dio to amar ase 2 times 10 millijoules. So 10 millijoules mane 10 into 10 raised to the power negative 3 whole divided by capacitance. Capacitance is 100 into 10 raised to the power negative 6. So ito ami calculator প্লাগ ইন কৰি দিওঁ তো আমাৰ ভ্যালু পাম 14.14 approximately volts fine তো আমি ভোল্টেজটো পাই গলো এতিয়া আমি আহি যাওঁ চাৰ্জলৈ so আমি জানো charge stored in the capacitor formula is q is equals to c times v তো capacitance হৈছে আমাৰ 100 into 10 raised to the power negative 6 মানে microfarad আৰু এটো মাল্টিপ্লাই কৰি দিও ভোল্টেজৰ লগত 14.14 volts তো আমি চাৰ্জৰ ভ্যালু তেতিয়া আমি পাম 1.414 into 10 raised to the power negative 3 or 1.414 millicoulomb fine etu calculator check kori loba moi directly value tu yate likhi disu to etu hoy goise amar charge junto capacitor to store hoy ase ite jehetu ami charge or kotha gom palo ite amar next part ot ahi jao in the case when the charging current is 0.1 ampere ta mane jetia ami battery source logot etu connect kori dilu to yate 0.1 ampere current flow hoisil ei current tu ei capacitor to charge kori asil तो second part to dhudha hoise je how long does it take to build up this charge ta mane 1.414 millicoulomb amount of charge build up hobole ba store hobole karone kiman homoy lagibo to ami jano je I part b karone I is equals to charge divided by time to here par ami time to ulai lobo parim so time t will be equals to charge divided by current to charge value to ami put kori diu 1.414 millicoulomb divided by current amar dia asile 0.1 ampere to etu ami calculate korilo to yar amar final value to hobo 14.14 millisecond so ekhini homoyr bhitorte 14.14 millisecond or bhitor ei capacitor to charge hoi jabo 1.414 millicoulomb আৰু ই এনাৰ্জি ষ্ট'ৰ কৰি ৰাখিব around 10 millijoules hello and welcome back to my channel so আজিৰ প্ৰবলেমটোত দিয়া হৈছে a figure shows the voltage time profile of an energy source used to charge a capacitor of 50 microfarad তো আমাৰ তাত এটা capacitor আছে ইয়াৰ capacitance value is 50 microfarad তো এই capacitor to charge কৰা হৈছে using some voltage source তো এই ভোল্টেজ আৰু টাইমৰ জনটো প্ৰফাইলটো হৈছে হেতু আমাক দিয়া গৈছে ক্লিয়াৰলি ফিগাৰটো পৰা আমি গমেই পাইছো যে ভোল্টেজ আৰু টাইমৰ মাজত এটা লিনিয়াৰ ৰিলেশনশিপ আছে that v is directly proportional to t তো আমি এই প্ৰফাইলটো ইউজ কৰি প্লাই ৰেট অফ চেঞ্জ অফ ভোল্টেজ উলাই লো সো ৰেট অফ চেঞ্জ অফ ভোল্টেজ মানে dv over dt সো এটো হ'ব v final minus v initial divided by T final minus T initial. The final voltage, to mane when T is equals to 10 millisecond, so our final voltage to is 20 volts, so 20 minus initial voltage is 0 volt. Our time to hobo 10 millisecond, so my 10 m bole likho 10 meter no to 10 millisecond, so 10 millisecond minus 0. So ito ami jeta solve korim, your value to ami pam 2 into 10 raised to the power 3 volts per second. Etia ei information to use kori ami find out koribo lagibo the charging current mane kiman current to use kori pele capacitor to charge kora hoisil to ami jano charging current or formula to hoise I charging equals to C dV over dt to C value to hoise amar 50 microfarad so 50 into 10 raised to the power negative 6 multiplied to dv over dt rate of change of voltage so 2 into 10 raised to the power of 3 so our final value to hoise 0.1 amperes